Oh, it's Mahdi. Here we go. And his research is AI-encoded solutions for decarbonizing AEC.
Okay, let me just start with that. That's not my research. It's the field that my research topic would emerge from. And we're going to discuss it a little bit later. So I'm an affiliated PhD researcher at ArchMenu. People make jokes that we are adopted, but yeah, back to you. My supervisor, Haeusler, and Sisi Zlatanova. And let's just get started. Before going through the topic, that's me, by the way. As far as I remember, I've always been interested in reading and learning systems and designing and writing systems, no matter what the source is. And in today's presentation, I'm going to walk you through these kind of sections. So keep that in mind. This is we'll be getting into that in like 2 or 3 minutes. So a little bit background from me. I'm a founder of Arduino.com, and these are some of our projects that's been going on. I'm a computational designer, but I am really interested in using codings, machine learning algorithms to solve our complex issues. So before getting through that, what is actually my topic? There is a big issue that I brought up Arduino into reality. And, this dispute between architecture, engineering, and construction. And we always start with pixel perfect design. And when it comes to reality, we need to consider, okay, there are some chaos, real world problems that the decision that we made at the first stage of the design need to be transferred into actions. But with those chaos, and real world, kind of issues, we need to consider different kind of filters, like time, cost, sustainability that we all talk about, but what's going to happen if we won't, consider them into design phase? That's the main idea behind, Arduino, and that is actually, I really like the most about ArchMenu because, there is the same structure to provide research into practice to solve this issue. So this is the most interesting idea of ArchMenu that brought me here. So if I do dive in, you can follow with these 2 highlighted words, like AI integrated and decarbonizing. So for having those filters that I mentioned throughout the design decisions, we're going to use AI, that Andrew Butler said something yesterday that this is just an algorithm we're talking about. So think of an algorithm, and let's just dive into that. All right, how an algorithm works with different parameters, and we're gonna get into that. And decarbonizing for my topic is just the pitch that I'm trying to play inside that. So the project is funded by WT Partnership. They are a quantity surveying company. They provide the data of time and cost. So you can see that I'm trying to synthesize these 2 with the algorithms and to decarbonize AEC, which is a topic, which is a broad topic, but we're going to make it a little bit into details. So back in AEC, the way we work is like we try to eat pizza, but face to face. Like we eat the bread, we eat the cheese, and we eat the topping layer after layer, and we expect it to taste like a trip to Italy. But that's not happening. We need more informed decisions to make, and we need an integrated thought, relying on the novel technologies to make things work. So between A, E, and C, we need that kind of integration. And if we want to decarbonize AEC, as a general idea, we need those informed decisions. So first thing first, we need to make those bridges between A, E, and C. So the idea of data interoperability among stakeholders come through, and although I'm going to provide more details, but keep that in mind that this is the main idea behind this topic. For doing that, there are some barriers, which are totally connected to A, as the colors follow. The tools in A, in architecture, is highly limited. They are not kind of like following engineering procedures. The flow of data in engineering back into the architecture phase is another issue. So I mean, all right, the engineer comes through making the design constructible, but they do not about the architecture insight behind the design. And when it comes to building life cycle, which I call it from the construction phase, there are some other issues. So decarbonizing is not just about selecting low carbon material. We need to, study more deeper layers. Within this diagram, you can find at the right side, thinking about my right or your right, the PhD focus of my topic would be just between decarbonizing, using material, computational design tools, and building life cycle, while at the left side, you can this informative graph. It shows that how regular material would be different from low carbon material. So throughout the building life cycle, if we consider this purple rectangle as the design phase, regular material tend to have lower cost at the beginning, but throughout the building life cycle after some years, that actually includes different like retrieval repairments, maintenance, taxes that comes from the sustainability issues. And it adds up more cost to the project. So by comparing these two deltas, inside some algorithm that we are going to dive in, we may consider a perfect definition for, all right, if I change my decision from regular material to a low carbon material, what would happen throughout the life cycle? That actually is the main topic that I'm trying to work on. But because this is a huge topic, we're trying to dive in into facade systems. As I mentioned, that I'm really interested in reading and learning about systems. With these 5 main reasons, we're trying to converge it into just a frame so we can deal with that. The first reason for selecting facade systems instead of a whole building, because that's really huge, is the diversity of geometry that we have at the facade system. So within a building, we may have different kind of systems of facade with different materials, so we can study them and learn, okay, what kind of decision made how many cost and time to the whole process of the building life cycle. Any kind of element that we have at facade system are highly precise, and you cannot go further, for instance, plus minus 1 millimeter, but you design these kind of glazing pans. And material at the facade system have shorter lifespans, so the data is quite rich, so we can actually study them. For example, we need to take care of the gaskets, the silicon sealants that they need to be repaired every 4 years. And there are curing process, there are different kind of approaches to make the facade works during the building life cycle, so that actually adds up to the data. And more importantly, number 4, manufacturers at facade systems need to satisfy architects because of the look, needs to satisfy the engineers, because those engineers need to follow, the standards, building codes, everything related to those products. And of course, they need to think about the assembly process when it comes to constructing a facade system. So the data that we have, or better say the decisions that we need to make within the facade system has to satisfy all of these sectors. So it's a good, like a rich kind of field, so we can, discuss about decarbonizing. And of course, the last one, which provides this kind of rectangle here, every decision that we make for designing a facade system is based on later stages. That's all of other decisions related to main structure has been made, and there is a solid stage to provide reliable decisions. So I mean, the precision of the decision at this stage is quite good and based on something that is founded already. So if I want to wrap everything up, I mentioned different approaches, but in these 4 stages you can follow all of the keywords that I mentioned. We need data interoperability, and for that we need to provide a common language. as you can see, for providing the common language between architects, engineers, and builders. We had an amazing experience with the recent hackathon. You can follow the poster at the exhibition. We actually tried to change 3D models into data so everyone can actually add, remove, or edit anything regardless of the software, file format, anything that they used for developing that specific object in 3D model. And that provides us the common language between A, E, and C. We need to follow the data throughout the life cycle, and it provides us the data granularity that we can, add up more details. I'm not talking about the beam data. There are many different things that we can add, like if the object is, constructible or not. And we also have the facade system, which I call them carbon nexus, because facade is something that controls whatever goes through a building and whatever, go out. And they are really impactful to control the, carbon emission, carbon embodied through the building, and based on the material, we can actually find those functions through the data. So, but if we want to have everything that I already mentioned in a specific scenario so we can study them, we need a reliable data structure. That's the main issue for this, I think, research, as you can see, to make machines become the friend of the human. We're not going to, just using the AI terms. As I mentioned, it's just an algorithm to help us find functional paradigm through data. For instance, can I have a light show through my design space, facade system that would help as a stiffener the structure's performance of my facade? Yeah, I can, but what kind of shape of that light show would get? These are functions through data that I'm talking about, so we can discuss this for the decision making, or better to say, making an informed decision, but by acquiring the sites from architects, engineers, and contractors at the same time. So that is specific data structure got my mind that, all right, think about it, how algorithm works. We have inputs, we have a function, we have outputs. And this applies to any kind of algorithm. And what AI can do is, finding those specific patterns among our big data. That is what we are weak in as a human, and we can use machines to do that for us. So if we think about how algorithm works, we need a structure to, provide us that potential kind of thought. And graph neural networks is actually work like that. So think about it, this schematic graph here. We have manufacturing process, material, building code and standards for every decision we need to make. And we actually make those decisions based on trackers that we have, like cost, time, and carbon footprint. Now, when it comes to graph language, we have entities as nodes, which you can actually follow from this graph. And we have edges, which we connect any kind of impact between each other by those edges. So when I want to make a decision about a facade system, for example, selecting a specific material or low carbon material, I need to think about how much time and cost this decision involves, and how this decision to select that specific material connects to the manufacturing process. And think of it that way. If I want to, expand the facade, I needed to, not facade element, but facade system, to expand that graph from that point. So we also could have different entities regarding that. And by developing this kind of graph scenario, we can find what kind of material, what kind of process impacts the other entities. So yes. Oh, okay. Yeah, I'm going to wrap it up. That's my last slide, by the way. So this is the whole structure of using AI algorithm, providing a tool for us to study the whole thing. And thank you.
Okay, questions, please. Complex?
Oh, yeah.
Sasha? No, I've got the microphone, of course.
Yeah, thanks, Mahdi, for the presentation. Very comprehensive.
Thank you.
And with a lot of information already. But I would like to know, since obviously it's a research-driven project, how do you measure then your outcomes, and how do you weigh in what kind of tool or learning mechanism is a successful tool to be used in the AEC sector to reduce especially carbon offsets, for instance?
Okay, that's a good one. But, basically, we're going to put this answer on the data that we have. The WLT partnership provides 30 years kind of like data regarding the recent projects, complex ones like airports, stadiums, whatever they actually have done. And there are decisions that they made already. And since we have the time and cost, we can follow what kind of decision actually were useful. So by measuring those attributes, we may provide something that give us this notion. All right, this decision was working, so we can apply it later. And that's the whole thing at the moment. I cannot guarantee that. All right, this decision can actually be applied in the future, but we just try to study what we had at the past.
Okay. Any further questions?
Thank you. Really interesting presentation and topic.
Thank you.
This is a broader question. So in your last slide with the graph of the different nodes, you had the building codes or construction as one of the key stakeholders that restricted everybody else,
Yeah.
right? Or you have to operate in that way. So my question is, how are architects involved in standards development? Because I know engineers in construction definitely are.
I'm not sure how they actually do it, but this is a process we always follow. When we want to design an element, there are some limitations, there are some building codes and standards we need to consider. For instance, when it comes to selecting a shape, a specific one, we have different codes to follow. And this actually is the main idea to connect our decisions to the engineering parts. I'm not sure if many architects do that, or they just like the artistic part to just the design, to design something. But as a matter of fact, this is the way these kind of building codes come through. We do not develop any of them. This is just like based on tests, and those standards came from those tests to limit the design in a specific, like, okay, with these materials you can do this. You can, have these kind of specific shape. And the way we filter those decisions is kind of related to those tests. That's what I have in my mind.
Yeah, so I used to be responsible for developing those standards.
Okay.
Would it be valuable to be involved earlier in those stages?
Yes, of course. Of course, I believe.
It's a
Yeah,
possible
we had a experience regarding one of our projects, and the test was saying something we needed to follow, but the complex of the structure was something else. And we called the test takers to provide a specific mock-up. Okay, so instead of using those standards, we started to develop something for that specific project, and architects were getting involved with those test takers. They are professionals; they know about the how to take these tests. And we kind of developed some specific codes for that project. Yeah. It's feasible to go through that,
very interesting.
but
Thank you.
It's not that normal.
No.
Good. Is there further questions? Yes.
Hi, thanks very much. Very energetic presentation, and
Thank you.
I don't know if this has come up already in conversations, but I would just encourage the work to get a lot more specific and narrow it down. And this is a conversation I've had with almost every PhD student I've worked with at this stage. You know, you're kind of covering the planet, you know, at the moment.
Yeah.
And I think it's great you've picked on facades, but I think even that is that's a huge subject. I think it would really help for you to be very, very specific about maybe even a particular place or a condition or a context. Because facades, you know, if you think, you know, facades carry so many conversations with them culturally. So, you know, whatever city you can think of randomly, Barcelona, London, Abu Dhabi, wherever, you could have a conversation about facades in that city, and then you could narrow it down to facades on the main avenues of that city and how they're used to convey other cultural conversations that might deny you the opportunity to open up a conversation. So maybe one thing, for example, just to pick on it, maybe conservation, you know, historical conservation concepts are fighting against our need to develop more efficient, sustainable, you know, architectures. So that's it, really. I mean, I just say there's so much energy coming from you off the podium, you know. It's really quite impressive. But I'd say just for the sake of the next couple of years that are ahead of you, you could easily narrow this down to, you know, 15% of what you're talking about and produce an excellent piece of work.
Totally get it. Thank you.
Good. Is there one more question or? No. All right, then thank you. Mahdi.
No, thank you.
So,